In the previous video, we examined the attributable fractions in the exposed group. In this video, we're going to look at the attributable fractions in the whole population, exposed and unexposed together. We call these the population attributable fraction, and for when the risk ratios or odds ratios are less than 1, we'll be looking at the preventive fractions for the population. So now, from a conceptual point of view, we're looking at the impact at a population for the whole population. And if we had an intervention to remove the exposure, what would be the impact on the whole population? If our data come from cohort studies or cross-sectional studies so that we can estimate risks or proportions, then we use this formula if the risk ratio or relative proportion is greater than 1. The population attributable fraction is the incidence amongst the total population minus the incidence in the unexposed group divided by the incidence in the total population. So incidence in the total population would be A plus C over the grand total, and the incidence in the unexposed group would be C over C plus D. Here we have a worked example, and you can work through this. You see the incidence for the total is 10 out of 30,000, and the incidence in the unexposed group is 6 out of 21,000. So you work out the incidences, and then you substitute in the formula from the previous slide, and we find that the population attributable fraction is 0.14. This means that 14% of cases in the general population are due to smoking. So if you were to remove smoking, you would only prevent 14% of the cases in the general population. Staying with cohort studies or cross-sectional studies, but now looking at something that's preventive, in other words, a vaccine against measles. So we now have a relative risk that is less than 1, so we're much more interested in does the intervention prevent cases rather than does it cause cases. So the population attributable fraction is not appropriate here. We rather want to get the fraction prevented, not the fraction caused. So the preventive fraction at a population level is simply the vaccine coverage rate times 1 minus the risk ratio. Very simple formula. The vaccine coverage rate in this example would be 1,500 out of 5,000. And the risk ratio came to 0.08. So we then calculate, and the preventive fraction at population level comes to 0.28. So what that means is at the population level, the measles vaccination is only preventing 28% of cases. This may sound odd, but look, the coverage is very poor in this particular cohort. It's only 30%. Now, what do we do when we've got a case control study? Remember, we can't estimate risks or relative risks with case control data. We can only work out odds and odds ratios. So we have to use a slightly different formula. Notice the formula is very similar to the one that we used for cohort studies for the population attributable fraction, but instead of risks or incidence rates, we're now using odds. The odds for the total means the odds of cases to non-cases for the total study sample is A plus C over B plus D, and the odds for the unexposed group is simply C over D. You can see that if you look up at the little table in the upper right-hand corner. So now going back to the example with pulmonary fibrosis and smoking, the odds ratio is greater than 1 because smoking increases the risk of pulmonary fibrosis. And so we're now looking at the population attributable fraction. But let's assume that we've got case control study data only, and we don't have cohort as we had before. So it's the formula that we were introduced to on the previous slide. And here's a worked example. The total odds are 20 over 50, which comes to 0.4. The odds amongst the unexposed is 12 over 35, which comes to 0.34286. And we then work out the population attributable fraction as being 0.14. So in the general population, 14% of cases are caused by or due to smoking. Now, what do we do if the odds ratio is less than 1? In other words, the exposure is preventive. For example, our vaccine and measles. Well, now, we're no longer going to do the population attributable fraction because that's not meaningful. We're going to rather look at the preventive fraction in the population. And for this, we need to know the odds ratio, which comes to 0.093. You can see I've worked it out for you here. And the preventive fraction for the population is equal to the coverage amongst the controls. So let's look at the controls. The controls were the people who didn't have measles. And the vaccine coverage there was 98 out of 372. So that's 98 over 372. And we multiply that by 1 minus the odds ratio. And the answer comes to 0.24 or 24%. This means that in the general population, about 24% of cases were prevented by this vaccination. It's low, but that is due to the fact that there is low vaccine coverage in this particular population. In closing, I'd like to point out that fact sheet EPI 01 summarizes all these formulae for you, so you don't have to memorize them. You can go and look through that, and it's a good way to revise for your quiz, because I'm telling you now that there will be 2 questions in your quiz which ask for attributable fractions. They will not involve the situation where the odds ratio or risk ratio is less than 1. So that's a little bit of a hint for you. If you find that you'd like to do more practice, look in your PDF booklet of exercises for this module and the next module. There's one booklet that covers both of them, and there's some additional examples provided there that you can work through. Good luck with the quiz.